We now discuss the solution of a problem from the section Matrices and Determinants. The given question is on the number of solutions of a given system of linear equations. And this question has appeared in the joint entrance examination main held on 25th June 2022 in the first shift. The given question is, let A be a 3 by 3 real matrix such that A multiplied by the column vector 1, 1, 0 is equal to the column vector 1, 1, 0. A multiplied by 1, 0, 1 is equal to the column vector minus 1, 0, 1, and A multiplied by the column vector 0, 0, 1 is equal to the column vector 1, 1, 2. If x is equal to the row vector x1, x2, x3 transpose and I is the identity matrix of order 3, then the system A minus 2I whole multiplied by capital X is equal to the column vector 4, 1, 1 has 4 options are given to us. Option A, no solution. Option B, infinitely many solutions. Option C, unique solution. Option D, exactly 2 solutions. We have a 3 by 3 real matrix capital A, and capital A is given with these 3 sets of equations. Then for that A minus 2I multiplied by the column vector x1, x2, x3 is equal to 4, the column vector 4, 1, 1. This system, this non-homogeneous system of linear equations has how many solutions? We are given 4 options and we have to choose the correct option. We now discuss the solution of the problem in detail. Let A be a 3 by 3 matrix and whose first row is A1, 1, A1, 2, A1, 3, whose second row is A2, 1, A2, 2, A2, 3, and whose third row is A3, 1, A3, 2, A3, 3. Now, the first, condition is A multiplied by 1, 1, 0 is equal to 1, 1, 0. Take the matrix A, multiply by the column vector 1, 1, 0, equate it to 1, 1, 0. Then you will get, if you multiply, first row and the column vector 1, 1, 0 will give you A1, 1 plus A1, 2, and here the first entry is 1. So, second equation is A2, 1 plus A2, 2 is equal to 1. A3, 1 plus A3, 2 is equal to 0. So, these are the equations what you get. Now, the second condition, A times 1, the column vector 1, 0, 1 is equal to minus 1, 0, 1. This implies the matrix A multiplied by the column vector 1, 0, 1 is equal to minus 1, column vector minus 1, 0, 1. Then the first equation will be first row and the column vector. So 1 multiplied by A1, 1. A1, 1 plus A1, 3 is minus 1. A2, 1 plus A2, 3 is 0. A3, 1 plus A3, 3 is equal to 1. So these are the 3 equations what we get. The last one is A times the column vector 0, 0, 1 is equal to column vector 1, 1, 2, the matrix A, and multiply column vector 0, 0, 1 will get A1, 3 is 1, A2, 3 is 1, A3, 3 is equal to 2. So these are the 3 equations what we got. So from these 9 equations, we have already got the value of A13, A23, A33, and from the remaining 6 equations, you must get the other values, that is A11, A12, A21, A22, A31, A32, so on and so forth. Now what we do is take these equations, and substitute in the above. So in this. So A13 is 1. So substitute in the first equation. A11 plus A13 is 1. That will A11 is equal to minus 2. And A23 is 1. So A21 will be minus 1. A33 is 2. So A31 is minus 1. So we will get. So that's why we got the entries of the first column of the matrix A. Now take this and substitute these values, substitute in this. So you will get, so substitute, so here. So A11 is equal to minus 2. A11 is minus 2. So A12 will be 3. And A21 is minus 1. A22 will be 2. And A31 is minus 1. So A32 is 1. So you will get these answers, these ones. So this is the entries of the first column, the entries of the second column, entries of the third column. Thus we got the matrix A. So matrix A is equal to the first column. The first column is minus 2, minus 1, minus 1 here, and 3, 2, 1 here, and 1, 1, 2 here. So we got the matrix capital A. We continue in the next slide. So A is this matrix and X is the column vector x1, x2, x3, and A minus, write down the system of equations. A minus 2i multiplied by X is equal to the column vector 4, 1, 1. So from the matrix A, subtract 2 from the diagonal entries. Write down here. So this is the minus 2, minus 2, minus 2 diagonal entries. From the diagonal entries, 2 is subtracted, multiplied by the column vector x1, x2, x3 is equal to the column vector 4, 1, 1. Now minus 2 means minus 4. Write down the equations. Minus 4x1 plus 3x2 plus x3 is equal to 4. And here minus x1, this is 0, plus x3 is 1, and minus x1 plus x2, this is 0, is 1. So we get these equations. So these are the system of non-homogeneous linear equations. So this is how what we get it. Now what you do is multiply the equation 3 by 3 and add to the second equation, then you will get the first equation. That means you will get the first equation as equation 2 plus 3 times equation 3. So that means these 3 equations will reduce to 2 equations only. That is minus x1 plus x3 is equal to 1, minus x1 plus x2 is equal to 1. So now suppose I want x2, I will write 1 plus x1, x3 as 1 plus x1, and x1 can take any value. That means x1 is equal to k. We will put k belongs to R, where k is arbitrary. So x2 is equal to 1 plus k, x3 is 1 plus k, and where x1 is equal to k is arbitrary, and these are the solutions. So x1 is k, x2 is 1 plus k, x3 is 1 plus k. So as k is arbitrary, it can take any value. We'll get infinitely many solutions. The system 1 has infinitely many solutions because k belongs to R is arbitrary. So k takes any value. Therefore, we'll get infinitely many solutions for this A minus 2ix is equal to the column vector 4, 1, 1. Great. So let's look at our options. Our answer, it accepts infinitely many solutions, appears against option B. Therefore, the answer to this question is option B. That is the detailed discussion of the solution of the problem from the section Matrices and Determinants, which is on the system of non-homogeneous linear equations and its solutions. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.